Hi, Math 3 students. Today we're going to go ahead and go over how to solve logarithmic equations. So as we know, there's a couple of different ways to solve these. You approach them differently when you have one logarithm versus when you have like a logarithm on both sides. So let's go ahead and take a look at this one. What your goal here is going to be is to get the log by itself. Okay, you want to get that guy by himself so that you can write it as an exponential and solve for x. So we can go ahead and add 11 to both sides. We get 6 log 3x equals 6. Divide by 6 so that that 6 goes away. Now we've got log 3 of x equals 1. At this point, the log is by itself. So we can write it as an exponential. You can say that 3 to the power of 1 equals x. You could go and plug that into your calculator, but maybe you don't need to. You can see here that x is equal to 3. Now you should always double check and make sure that it's a good solution. If we go plug a 3 in here, we're good to go. We get a positive value. So 3 is our answer. All right, let's see. Let's try this one here. So let's go ahead and add 19 to both sides. So I get negative 4 log of x equals 12. Then we're going to go ahead and divide each side by negative 4. And I lost my 8 here. We get log base 8 of x equals negative 3. At this point, my log is by itself, so I can go ahead and write it as an exponential. So I get 8 to the power of negative 3 equals x. Now, some of you might be able to do this in your head if you have your cubes memorized. Otherwise, you could just go straight to your calculator. You do 8 to the power of negative 3, math, enter, and you get 1 over 512. And of course, you want to double check that it's a good solution. It's positive in there, so we're good to go. So again, when you have equations like this, your goal is to just get that log by itself and then write it as an exponential. All right, now here. Here we have 2 logs on the same side. And what we're going to try and do is condense it so that we only have 1 log on that side. So if we look here, we know that a plus sign tells us to bring the logs together and multiply what's on the inside. So we're going to do log base 2 of, and then we get 9x times, and then remember this 2 needs to come up here, so we get 8 squared. All right, so we can actually go ahead and just multiply what's on the inside there. We get 8 squared, which is 64. And then we multiply it times 9. We get 576. So we've got log base 2 of 576 x equals 3. So then we can go ahead, write this as an exponential, and solve for x. So we get 2 to the power of 3 gives us 576x. 2 to the third, running out of space here. 2 to the third gives us 8, so we've got 8 equals 576x. We divide by 576. 8 divided by 576. Math, enter. And that gives me 1 over 72. Of course, we go look. Can we plug 1 over 72 in? Yes, we don't get any negatives on the inside, so we are good to go, and that is our solution. All right. Let's try this guy. Similar concept. We want to get this down to 1 log here. So we end up with log base 2. Now we know when we have a subtraction sign, this stuff gets booted to the denominator. Also, don't forget to bring that 4 up to become the power. So we end up with 2x over 3 to the power of 4 equals 1. So we could go ahead now and just write it as an exponential. So we get 2 to the power of 1 equals 2x over, and then 3 to the power of 4 is 81. So now we've got that 2 is equal to 2x over 81. If we're working to get x by itself, I'm going to go ahead and multiply. You could either multiply by 81 over 2, or you could multiply and then by 81 and then divide by 2. I don't care, whatever floats your boat. So we get 81 times 2. We get 162. Then we divide by 2. And we get that x is equal to 81. And of course, we can go ahead and check, does that give us a good solution here? Yep. So that is our answer. All right. Okay, let's go ahead and try this one. So we want to go ahead and rewrite this so that we have a single logarithm. So we end up with log base 4 of 2x squared minus 4 all over 3x plus 5 equals 0. So now we've got a single log. We can go ahead and write it as an exponential. So 4 to the power of 0 gives us 2x squared minus 4 all over 3x plus 5. We know that 4 to the power of 0 is 1. Anything to the power of 0 is 1. So that becomes a 1 there. Now we need to work to go ahead and get x by itself. Now if you notice, right now looking at this, it looks like we're going to be left with a quadratic. So we want to get all the x's on the same side. However, having x's in the denominator isn't super helpful here. So we want to get rid of that stuff in the denominator. So we're going to go ahead and multiply both sides by 3x plus 5. We would distribute this, but it's just a 1, so nothing's really going to change there. So we get 3x plus 5 is equal to 2x squared minus 4. Now, we're getting closer to a nice quadratic here. We got to get everything on the same side. Remember, you want to keep the guy with the highest power positive, so that's why I'm moving the 3x and the 5 over as opposed to the 2x squared and the 4, because I don't want to make this guy negative. All right, so we're going to go ahead and subtract 3x and subtract 5. So we get that 0 is equal to 2x squared minus 3x minus 9. So now we have to go and factor. And we can see here that we cannot do the easy method. We're going to have to do AC factoring. So we do 2 times negative 9 gives us a negative 18. What two numbers multiply to negative 18 and add to negative 3? That's going to be a negative 6 and a positive 3. So then we're going to rewrite my negative 3x with a negative 6 and a 3. So we've got 2x squared minus 6x plus 3x minus 9. Now we've got to do our factoring by grouping. So we take out a 2x and we get x minus 3. Here we can take out a 3 and we get x minus 3. So now factored, we've got 2x plus 3 and x minus 3. So now we have solved, well, no, we haven't solved, but we factored the quadratic. Now to solve, we have to set each of our factors equal to 0. So we're going to do 2x plus 3 equals 0, and x minus 3 equals 0. We subtract 3 from both sides, we get 2x equals negative 3. We divide by 2, and we get x equals negative 3 all over 2. Here we just have to add 3 to both sides, and we get that x is equal to 3. So that was a lot of work. These quadratic ones are definitely a little bit more challenging. All right, so now we have to go ahead and check our answers and make sure that they're good answers. So remember to do that, what we have to do is anything that has an x with a log, we have to take our answer, plug it in, and make sure that we don't get a negative. So first we'll go check our negative 3 over 2. That guy looks suspicious, right? Because he's already negative to begin with. Let's check. So we'll do negative 3 over 2. 2 times negative 3 over 2 squared minus 4. So that was me plugging it into this logarithm here. And that one checked out. That gave us positive value. So then we're going to do 3 times negative 3 over 2 plus 5. And that one's also good to go. So both of those, it worked. So negative 3 over 2 is a good solution. And then we could plug a 3 in. Make sure that gives us a good solution. That works there. And it works there as well. So these are our two solutions to this one. All right, let's try number 8. All right, so again, our goal here is going to be to condense this down to a single logarithm. So this plus sign implies that we should be using multiplication. So we end up with log, oh, I don't know why I wrote a 7 there. Log base 7 of, and we have to multiply this stuff on the inside, right? So we get 2x minus 1 times x plus 3 equals 2. So before, when we were multiplying stuff on the inside, we ended up just with one term, right? We didn't have to FOIL or anything. Well, here, now we do have to FOIL. All right, so we get log base 7 of, and we FOIL this out, we get 2x squared plus 6x minus x minus 3. So now we've got log base 7, 2x squared plus 5x minus 3 equals 2. So at this point, we've gotten it down to a single logarithm. We can write it as an exponent. So we're going to say 7 squared is equal to 2x squared plus 5x minus 3. 49, or 7 squared is 49. We want to get, it's quadratic, so we want to get everything on the same side. So we do minus 49, minus 49. So we get that x, not x, 0 is equal to 2x squared plus 5x minus 52. All right. So now we have to go ahead and factor this out. So unfortunately, we got to do AC factoring. We don't have a GCF here. So 2 times negative 52 is going to give us a negative 104. So this one definitely I would write out the factors for. This is kind of a more challenging factoring problem. So, you know we can do 1 and 104. Let's see, 104 divided by 2. We can do 2 and 52. I don't think 3 is going to work. And remember, when you don't know the answer, just start with 1, 2, 3, and just keep going until you figure it out. So obviously 3 is not going to work there. 104 divided by 4 should work. We get 4 and 26. 104 and 5 won't work. 104 divided by 6 doesn't work. 7 doesn't work. 8 does work. We get 8 and 13. I don't believe 9's going to work. 10's not going to work. 11 doesn't work. 12 doesn't work. And then we're repeating. So we found all the factors of 104. And now we know we want to multiply to a negative and add to a positive. So that tells us that one of our guys is going to have to be negative. And we want the negative one to be the smaller number so that it adds to a positive. So my two numbers here that are going to work are negative 8 and 13. So I've got 2x squared minus 8x plus 13x minus 52. And then I'm going to go ahead and take out my GCFs. So I can take out a 2x here. And I am left with x minus 4. Here, hopefully I can take out a 13, I would imagine. Yep. So we can take a 13 out of this, and we get x minus 4. So we are left with 2x plus 13 times x minus 4 equals 0. We can go ahead and solve these. So we get 2x plus 13 equals 0. X minus 4 equals 0. We're going to subtract 13 from both sides. We get 2x equals negative 13. We divide by 2, and we get that x is negative 13 over 2. Then we add 4. We get that x is equal to 4. Now, of course, we need to go check our solutions here, right? Make sure that they are not extraneous. So we're going to plug in our 13 over 2. So we're going to do 2 times negative 13 over 2 minus 1. And when I do that, I get a negative 14. That ain't good, right? So that guy is rejected. You could go and check him in here as well, but once it gives us a negative value in any of the logs, it's out. So we can stop checking it and cross it out. Then we're going to go check our 4. So we've got 2 times 4 minus 1. That one's good to go. And then 4 plus 3 is 7, so that's good to go. So 4 is a good solution here.